now look at functions. So let's suppose a and b are non-empty sets. So a function f from a to b is an assignment of exactly one element of b to each element of a. And we write this as f of a equal to b, if b is the unique element of big B assigned by the function f to the element little a of big A. In addition, we write functions using this notation, f colon a to a arrow b. So this is read a function f from a to b. And if we have this function from a to b, we'll say that a is the domain of f and b is the codomain of f. If f of a is equal to b, we say b is the image of a and a is the preimage of b. And the range of f is the set of all images of elements of a. So also if f is a function from a to b, we say f maps a to b. So here's some examples of functions. We have this first one, where everything in A goes to one thing in B. And this we can have the case where two things go to the same element. The main thing is everything in our first set A must be assigned to one element in the set B. Same thing here. Every single element in A is being assigned to a single element in B. These are examples of non-functions. So for example, this first one here, we have this issue here that C is not being assigned anywhere. So that violates the condition of being a function. Our second one, B is not being assigned to a unique element. It's being assigned to two different elements. So this also violates what it means to be a function. So let's consider the function f of x equal to x squared. In this case, our domain is all of the real numbers, everything from negative infinity to infinity. The codomain is also negative infinity to infinity. However, our range are the numbers 0 to infinity, since there's actually no value of x that would give a result of -1. We can also do algebra functions. So if f1 and f2 are functions from a to r, we say f1 plus f2 is equal to f1 of x plus f2 of x. f1 times f2 is f1 of x times f2 of x. So for example, we're going to let f1 be equal to x squared and f of 2 be equal to x minus x squared. So if I want to find f of 1 plus f2, then I have f1 is x squared, f2 is x minus x squared, and once I add those, I get x. We can also multiply f1 times f2. That gives us x cubed minus x to the 4th. So a function is said to be one-to-one, also known as an injunction, if and only if f of a equal to f of b implies that a is equal to b for all a and b in the domain of f. And it's said to be injective. So basically, the idea of one-to-one is we know that every element of a has to be assigned to a unique element in b. And this is going to prevent two numbers, or two elements of a, to being assigned to a single element of b. So for example, let's determine if this is a function. So whether the function is one-to-one. The best way is to draw the arrow diagram. My first set is A, B, C, D. My second set, 1, 2, 3, 4, 5. And I can see that every element in my first set goes to a different element in my second set. So this one is one-to-one. We'll look at this one, which changed slightly. And we'll notice every element of A does go to a different element of B. Therefore, this one is also one-to-one. We'll do a third one, once again changed slightly. We have this new arrow diagram, and this is not one-to-one, mainly because every element of A does not go to a different element of B. We have two things going to 4, both A and to E, so this is what violates the one-to-one condition. We'll do one more where it's changed slightly. Once again, you can see this violates the condition because I have both B and C going to 1. So this is not one-to-one. A function is said to be onto, also known as surjection, if and only if for every element little b in big B, there is an element A in big A, with f of A equal to B. This is also called surjective. So the idea of this is we know that every element in A has to be assigned to some element in B. However, I can have extra stuff in B. That's the difference between the codomain and the range. For an onto function, the codomain should be equal to the range. So for example, we said that this function was one-to-one just a second ago. However, it is not onto because of this value right here that's not having anything assigned to it. My second example, this one was also one-to-one. And this one is onto because you'll notice everything in B does have a pre-image element. Everything has something mapping to it. My third example, this one was not one-to-one. In addition, this one's not onto, so this one is neither because of this to element that doesn't have anything assigned to it. My final example, this one was not one-to-one. However, it is onto because everything in the second set has something being assigned to it. So we did 4 examples, one that was both, one that was neither, and then one that was one-to-one and onto, one that was one-to-one and not onto, and then one that was not one-to-one and onto. So we can have any combination of these two properties. And in addition, a function is said to have a one-to-one correspondence, or a bijection, if it is both one-to-one and onto.